Right, hi there, class. Let's talk about running some item analyses in some software packages. Uh, I found a really cool package in a user-written package in Stata that runs item analysis for you and has a very nice display for it. So you'll need to actually install this module from it's from UCLA, and so here is the syntax to install it. Once you've installed it once, you don't have to do it again. Now, I don't know about running this on the virtual machine. You might have to install it every time from there, but so go ahead and run it. It'll install the module, and then let's look at the help file for the module so you know what's going on. So this is the multiple choice item test analysis. You can see the syntax is pretty easy. MC test, give it the variable list, and then here are the different options. If you want it to generate a total score variable, you just use generate and then the variable name. For the discrimination index, you would use this centile. I think it defaults to quartile, so it would be the lower quartile would be the lower performers, the upper quartile would be the top performers. If you want to change that, you can give it a different integer here. If you want the program to score your data, where it would create a variable where it'd be like question 1 and whether the person got the answer right or wrong, so it'd be a 0, 1. You can do this and you just give it the prefix. So if your question was Q1 and you put the whatever prefix you put in here, it'll just put that before the variable name. So it'd be like if you put C in here, it'd say CQ1. And then the delete option is if you want like the point biserial correlation computed where you delete the item from the total score. And you can read, I mean, all the options. It says the same thing right here. So it's documented there. One of the important things to note is actually how you have to organize your data for this to run. So you notice the first line in the data file has to be the answer key. So if A was the correct answer to number 1, that needs to be in the first row, first column. If B was the correct answer to question 2, that should be in the second column of the first row. So the first row in the data set must be the answer key. The second row in the data set has to have the number of options, number of multiple choice options, right? So if you had A, B, C, and D options, you had 4 options, you'd need a 4 all along that second line in the data set. So basically you just have to tell it, you know, this variable had how many response options. And then the rest of the lines in the data set are the individual's responses to the item. So person 1 answered C, person 2 answered B to the question, person 3 answered A to the question. And so it's set up the same way you'd have your file. And so you can see some example syntax and then the author here. So I've already set up a data set this way. You should be able to download this from Canvas. It was that same file you saw in the Excel video. I just added those top 2 lines that we needed to format it for this program. So we can go ahead and load that into Stata. So I'm going to load it. And then I'm also going to create an ID variable. So if I want to run like descriptive statistics for the total score, or you want to run like a reliability alpha to get the alpha if the item is deleted, I want to be sure to select out those first 2 rows right out of there. So I'm going to create an ID variable here that would let me select out those rows. So let's open up Stata and we can see, try to make these a little bit more so we can see what's going on here. Here we go. We can look at the data set, and you can see, remember, there were only 10 people who took this quiz. So their data actually start on row 3 here. So question 1, the correct answer was option D. Question 2, the correct answer was A. Question 3, the correct answer was A. And then notice row 2 all has D's because there were 4 options, and we have D coded as 4. So that says D all the way across here. So notice this file just has their actual response to the question, some information about whether they were male or female and whether they were a psych major or not. And there's the ID variable that I created. Okay. So let's go back to our syntax and let's go ahead and run our item analysis. So remember, we already talked through what the syntax looks like. I already gave a little description of it here. So it's just MC test. We want question 1 through question 20. I want to calculate the point by serial correlation by deleting the item from the total score. I want to generate a total score, and I want to call it score. And I want the program to actually score the test. I wanted to create 20 new variables. They'll start with the letter C, so it'd be CQ1. That would just indicate that whether the person got question 1 right or wrong with the 0, 1 option. So let's run this. And here is our item analysis. So you can see there were 20 items and a total of 10 observations, and then the point by serials were computed with the item deleted from the total. That's what we asked. So you can see here for question 1, remember we found that it was a pretty difficult question. Only 10% of people got it right. The discrimination index is 0. Remember, so this was the average high performer score minus the low performer score. Remember, no high or low performers got it correct, so the discrimination index was 0. There's the point by serial correlation. So that's another indication of the discrimination coefficient. Remember, we want to see these be positive. It shows that higher ability students are more likely to get the question right. Remember, you interpret this correlation the same way you interpret any correlation. That as you're increasing on the total score, if it's positive, it's pointing to the high performance group, the group labeled 1. If it's negative, it's pointing towards the lower performers. So this is saying lower performers tend to get this item correct. Well, really, there's only one person, right, who got this item correct. And you can see they were in the middle group here. So this is just the proportion who selected each item, right? 10% selected D, that was the right answer. 30% selected C, 20% selected B, and 40% selected A. And then here is sort of this is basically your distractor analysis. You can see the proportion who answered the question correctly, or the proportion who selected that response in both the low and the high performers group. And then there's the middle 50%. And here is the discrimination coefficient, the point by serial correlation for each response option. Notice the correct response is indicated with a star here. You can see the point by serial correlation is the same for the item. Right. So remember, we want to see positive discrimination coefficients for the item and negative discrimination coefficients for the distractors. When we see a positive discrimination for a distractor, it means that higher performers are attracted to that item. So it means something's going on. So apparently question 1 was just really difficult. Nobody, only one person seemed to get it right. Either we need to cover this concept better in our lecture, or the question's worded poorly and people aren't able to answer. We need to figure out what's going on here. Question 2 was the exact opposite. It was too easy. Everybody got it correct. So you say there was no discrimination at all. Question 3 was also pretty difficult, but something strange is going on here too. The lower performing students tended to get question 3 correct, and the higher performing students tended to get it incorrect. Actually, none of the high performers got it right. All the high performers said, all responded with option 2, all responded with B. So this is again an instance where we'd want to go back, look at the question and see, is there something that, the high performers, why are they gravitating towards option B? Is the question worded in such a way that, it leads them to B instead of to A? Is it something where, if you had partial knowledge of the question, you would just, oh yeah, this is it, and you'd gravitate towards it? So really we want to find out what's going on here. Question 4 is a similar thing. Only one person got it right, only 10% of people. And it was someone in the middle 50 who scored midway on the assessment. So we'd probably want to take a look at that item too. Question 5 was so it was just one high performer here on this who got question 5 correct. The other responses, we see that some of the high ability students and some of the students in the middle were attracted to option A, or the first option. And then, so what we really want to see for a distractor is something like this, where the lower performing students are more attracted to a distractor. So question 5, it was apparently pretty difficult. Only one person got it correct. We want to see kind of what's going on here. Question 6 performs a little bit better. About 60% of people got it correct. All of the high performers and a little over half of the low performers got it right. But also nobody selected option C or D. So we might want to look at this question again. Is it just so obvious that those are not the correct response that nobody selected? Same thing with 7 here. No one selected responses A or B. Maybe we want to look back at those and say, are those response options just so ridiculous nobody's going to choose them? Is that what we want to happen? So this is, remember, an item analysis is really just a way for you to quantitatively analyze a question set. And so we'd basically go through all of our items like that. We'd actually take out the test, review it as we're doing this to see, oh yeah, something does seem up with what's going on. Let's take a peek at the data so you can see what it did. Remember, it created a score variable for it. We told it to create a new variable called a score. So this was the same as the total score we had in the Excel file. And then it also created created 20 new variables that indicated whether the person got the question right or wrong. So it scored the test for us. So you can see the only person on row 6 got question 1 right. We knew everybody got question 2 correctly or correct. So you can see that's what it added to the data set. One thing that this doesn't give us is sometimes we might want to be interested in, the reliability of this. How well do the items measure? How well do the items fit together? They measure this construct under study. And so we would run, an alpha reliability coefficient. So we can do that with the scored items, right? So we'd want to use the dichotomous 0, 1 items here. And so we can use in the alpha command, we're going to use our new scored item CQ1, CQ20. And then this is why I created that ID variable, because I only want to run the alpha if the ID is greater than 2, right? Because I only want the reliability for the 10 people in there, not the first. I want to exclude the first 2 rows in the data set. And then I want them to keep the items as they are. So we're going to leave the as is command. I don't want it to automatically, recode negative items, because on this test, we would hope that all the right answers should contribute positively to the total score. I don't think I need the details, but we'll leave that in there anyways. So there's our inter-item correlations. We really just want this top part. So this would be the point biserial correlation, and here is the point biserial with the item deleted, right? So we still get that same information. Notice it skips from 1 to 3. It deletes, Stata actually deletes items that don't contribute any variability to the scale. So they were dropped, constants were dropped in the analysis. So we might want to get rid of those anyways. Either everybody got the question right or everybody got it wrong. We want to, see what's going on with that item. You can see the reliability for this scale is pretty poor. So we might want to consider, what are we going to do with these items? So remember, any kind of item analysis is really an iterative process. So what we might do is we might rerun the item analysis. Remember, we talked about questions 1, 2, and 3. One was really difficult. Only one person got it right, and it wasn't in the high or low group. Question 2, everybody got it correctly, so it wasn't doing anything for us. Question 3 was really difficult. And then if you went back through there, question 9, 14, and 15 all seemed kind of wonky, and something was going on with it. So I'm going to rerun the item analysis with those dropped. And we can see now our item analysis is starting to look more like what we would hope. Question 4 is still a really difficult item. Only one person got it correctly. There's one person in the high ability group. We still see some in the high ability group are being distracted by option 2 on question 4. And notice that our high and low ability groups changing because the total score our score changed because we dropped items. So, our point biserial correlations will change slightly from what they were before, and then the distractor ones distractor discrimination will also change. But they're still in the positive direction of kind of what we would like to see. Here for 6, still nobody chose these other items. So, we might want to look back at those response options and see what's going on. This is more of what we would like to see. this question was, about 70% of people got it right. It did a good job discriminating between the high and low group. The lower ability students tended to gravitate towards options A and D, and B was the correct answer, and all of the higher performing students got it correct. So that's kind of what we like to see, that the discrimination for the correct response is positive and negative for other responses. Here, nobody chose those responses. So we would go through that analysis again and see, we still, it looks like 12 here seemed to be a pretty easy question. 70% of people got it right. And, it was, the majority of high and low performing people got it correctly. And they were also attracted to item C. So we might want to see kind of what exactly is going on with 12. So, we would run through the same, kind of do another iterative process with it. We could run our alpha again. Let's run it unstandardized this time. And I don't think I need the details either. Those are just that correlation matrix. And so, look, we have a pretty decent reliability now for the test, 0.73. We could look here again, are the, this would be the uncorrected point biserial correlation. Here would be the corrected. Notice that the corrected is all a little bit lower, right? Because we would expect, an item correlated with the total that included that item to be higher. So we get all those same values with the alpha. If the item's deleted, we can see if really deleting any of the items, it looks like 12 would improve the alpha somewhat, 0.76. That's a little bit better. Maybe we want to see what's going on with 12. We would rerun this process again. So that is one way you can do an item analysis in Stata. I thought it was a really neat program that that organized the output for you pretty nice. If you wanted to get some descriptive information for your test, you could test for differences between groups. Did psych majors perform better than non-psych majors on the test? We could run a t-test looking for differences in those groups. I'm going to use the second score with the items that we dropped. Score based on those items. Let's run. There's our t-test. It looks like there is no difference between, or there's not a statistically significant difference. So those who were psych majors scored slightly higher than those who were non-psych majors, but the difference isn't statistically significant. Remember, there's only 10 people in here. There's not very much statistical power. We can look at the effect size. The effect size is pretty large, but again, look how wide the confidence interval is on it. It's again a function of just the sample size. Again, here is, really I'd ask myself, what was the difference here? A 2.5 point difference meaningful or not between those? But I'll put some more syntax in here if you wanted to look at differences by gender. If you wanted to take the total score or get some descriptive statistics for it, you want to get a percentage, what percent did they do right? So there's some syntax in here that you can mess around with and do that. I also wrote up some syntax in SPSS for you to do an item analysis in SPSS. These are really easy stats to do that you can really do in whatever program you feel most comfortable in, like that. They're easy enough to do in Excel too. The item difficulties is just, the means of the items. You want to make sure they're dichotomously scored, right or wrong, and we can get, so here the item means, you can see, again, question 1, 10% got it right. The difficulty was 1 in question 2 because everybody got it right. So you could use either the descriptors command or the means command to get the same thing. If you haven't already created your rankings for your discrimination index, you could use the rank variables command and create, go ahead and rank the variables. We'll run that. And then if you want to get the discrimination index, basically what I did was just run a t-test between the groups for the high and low performing groups on your ranks. And then the mean difference reported in that output would be that discrimination index. That was just the only thing I had to think of off the top of my head to get this really quick. So the discrimination index would be the difference between these two values. And you'll see that difference reported here, mean difference. So that would be your discrimination index. If it's not reported, like question 1 or 2 is not reported, that means the discrimination index is 0 because either everybody got it right or everybody got it wrong. So you can see. So it's if you want the point biserial correlation, the one that was uncorrected with the total, you can just run a correlation, and you'll see those were those uncorrected point biserial, so the correlation between the item and the total score. To get the corrected one, we could do that in the reliabilities command, and we could look at the item total. We could look at the item total correlation here. So here is then the discrimination coefficient for each of those items corrected. So it's the correlation between the item and the total score without the item in it. And you can see, so SPSS doesn't drop ones without variability like Stata did. So you'd actually get the zeros in here too. I like the discrimination coefficient is better than the index, just because the index we're dropping, a good proportion of our sample from that analysis. For distractor analysis, basically I just wrote a really quick a macro here that just recodes the variables and then runs the a correlation between the. So I just basically rescored the variables as if A was correct on all of them, as if B was correct on all of them, as if C was correct on all of them, and as if D is correct on all of them, and then run the correlation with the total score on that item. So this would be the uncorrected point biserial correlation. We'd have to actually recompute the total score each time too. But it just gives you an idea. Let's just run those. Kind of a distractor analysis for each one of those response options. So you can see this would be. So here's our distractor for question 1 for our response option A, response option B, response option C, and response option D. Remember, D was the correct answer. And now these would be the uncorrected, right? So this is with the item in the total score calculation. So this isn't going to match what we got in the Stata output unless you take out the delete option there. Then you can see there was no discrimination for the other ones because everybody got that one right. And then you can see the discrimination index. There it is for A, B, C, and D. You can kind of play around with that syntax. See, you might have a better way of doing these. This is just one way I thought of doing it in SPSS. I also found a couple R packages that will run an item analysis for you. Some of them are really finicky about the way it wants the data set up. So I have some R syntax, some R script on the on Canvas that this right here that will that you can kind of play around with. There's this cool SJ plot I found. Also found another package called CTT, Classical Test Theory. And there was another package called Item Analysis, but I could never get the data set up correctly for it to work. So if anybody wants to search for Item Analysis package in R and play around with it, see if you can get it to work, that would be great. So if you haven't installed the packages, you can install them here. We can run it. We're going to import that same Excel file data here. I'm going to select out just the dichotomously scored items. So let's just run all of that. And then I'll run the item analysis in this SJ plot package. What it's going to do is just going to run an item analysis, and it's going to output it in the viewer window over here, which is nice. Okay, so now here is our item analysis data set, and these were just the binary items for the 20 variables. So we can run, we'll just go ahead and run this line so you can see what the default looks like. So you can see it points out, so here it is, question 1, there was no missing. The item difficulty or mean, remember only 10% got it correct. It gives you the standard deviation, the skewness, the difficulty. This discrimination parameter is the corrected so it would be the point biserial correlation between the item and the total score with the item removed from the total score. So it was the corrected one. And here is the alpha if the item was deleted. So and this was, I believe, the unstandardized alpha. And so you can see, and it points out in this nice table here. You can also, there was a couple options in here that you could get the kurtosis value and a normal test. Let's see. Did it pop out? It looks like that one. Oh. Well, maybe that item. Did that work? All right, well, that code, we'll have to play around with it, try to get it to work. There was also the classical test theory package. So we can run the item analysis in here with the binary items. Have to actually tell it that it's a data frame to make it run. And then, so it looks like it ran it and it saved out a report for us. So let's review the item report. And so we can see here, so question 1, we get the item mean, we get the corrected point biserial correlation, we get it also computes the just the biserial correlation which they're both kind of getting at the same idea. It's sort of a different philosophy behind it, but it's still a correlation between a dichotomous variable and a continuous variable. Its idea is if like the dichotomous variable is really a variable that's supposed to be measuring a continuous variable, that, so say you had like IQ, we're going to correlate IQ with test scores, but all we had for IQ was whether they were high or low on it. If you did like a biserial correlation, it's supposed to recover what that underlying Pearson correlation would be between the continuous IQ and grades instead of just between the dichotomous IQ and grades. And you can see it's typically a little bit stronger than the point biserial. And then you also have here the alpha if the item is deleted. You can also get some additional like statistics just on the scale. Well, so we have, why does it keep doing that? So here we go. We get the number of items, number of people, the alpha for the scale mean, and the scale standard deviation. It's all saved in there. So those are just several ways you can run item analyses in some different software packages. In class this week, we're going to just go through an activity. I'm going to have you run item analysis. You can use any of these that you want. As always, if you have any questions, shoot me an email, post something on the message board. I'm available. I look forward to seeing you all in class. Thank you. Bye.